Welcome, my name is Eugenia Stamboliev, and I have the privilege to host today's session on innovation in the AI age. I also am very, very happy and pleased to host two amazing speakers I will introduce shortly. Just a little bit on the format, so we're going to have two talks, two keynotes, and after each Q&A. But of course, as usual, please be as brief as possible so we can get in as many people as we can to ask questions. I was curious in how to introduce this session and if to say something or not. Usually I should not, but then of course the idea of innovation actually triggers me a little bit because I used to work in media studies and we used to talk about early cinema and very old things actually that are not considered innovation. And then I remembered a professor of mine who once wrote a book on the new, and I would like to quote something out of this, just as an inspirational quote to start today. So Boris Groys is a media scholar and professor who wrote in 2014 a book on the new. Back then, I don't know if some of you remember, we were talking about digital media, but also new media. Everyone's talking about new media, and then we stopped because we realized it's actually not that new. I quote, "To ask about the new is equal to asking about value. Why do we attempt to say something at all? To write, paint, or compose something that was previously not there? Why does the belief in the value of cultural innovation of our own come from, if we know from the outset that the truth remains inaccessible? In our desire to be creative ourselves, we are perhaps just succumbing to a diabolical temptation that we should, in fact, resist in order to maintain our integrity. To ask the question another way, what is the sense, what is the point of the new? These questions are premised on an unquestioned conviction, namely that the desire for the new is the desire for truth." End of quote. Well, is this like that? Can we find new truths, new forms of creative potential, actually? Of course, this is a bit more a creative or media perspective. But yeah, let's see what we're going to hear today about innovation and AI and new or older things. Yeah, we have to put everything into context anyway. And to introduce my first speaker is a really, really great pleasure. A little bit of a background. I, of course, Googled him and tried to prepare, and then I found a CV of, I think, about 40 pages. It's impossible to summarize such a work and so many achievements. So I have to be brief. And the first speaker is Professor Michael Cusumano. He's the SMR, Distinguished Professor of Management at the MIT Sloan School of Management. During 2020 till 24, he was Deputy Dean for Faculty and Research, and he also held a joint appointment at the MIT School of Engineering. Cusumano specializes in strategy, product development, and entrepreneurship in computer software, and many other things. He has consulted and lectured various over 100 companies and organizations, and is currently the director of Oryx Corporation in Japan. He has served as editor-in-chief of different outlets, but of course of the MIT Sloan Management Review, and he writes regularly for different journals. And he has published 14 books, at least I hope that's up to date, and over 100 articles. And his latest book is The Business of Platforms, A Strategy in the Age of Digital Competition, Innovation of Power. That came out in 2019, I think, if I'm correct. And there's much, much more to say, but I'll leave it here. He will tell us something about Gen AI as a new innovation platform. And these are my last words for now. Michael, the stage is yours.
Okay, thank you. All right, I need to move quickly, otherwise I'm going to run out of time. It seems like my voice is too loud. Is that not the case? No? Okay, so it's just the echo here. All right, Gen AI is a new innovation platform. So yesterday we had some discussion as to what is a platform, is the term even useful? I will resolve all of those problems with one slide. So I have been writing about platforms with my former doctoral student Annabelle Gower, who should be here somewhere, and also David Yaffe of Harvard Business School. But in 2019, 2013, we did publish this book, The Business of Platforms. And so yes, as Lawrence Lessig said on day one, platforms, they are a business model. They can have nefarious purposes as well as good purposes, but they are a business model. I look at them more as a kind of a technology stack, but the basic purpose is to link actors in a market who would not otherwise easily connect with each other. And that happens in two different fashions. In our book, we broke down kind of all platforms into two major types. The first type that I've been writing about since a book called Microsoft Secrets back in 1995, we call innovation platforms. And the purpose there is that stack of technologies in the middle brings together users with innovators, essentially third-party application and service developers. And there's, again, a stack of technologies. There's an Intel or Intel-compatible x86 microprocessor at the bottom. There's a Windows operating system. The technology is inside a box that we call a personal computer. And then there's applications on top of it. The other type of platform that emerged primarily with the internet, but some other prior technologies, we call transaction platforms. And here, the two sides of the market that are being brought together are people that want to interact with each other, buyers and sellers, people with messages to send to another person, or advertisers that want to reach those people who are sending messages. So any type of system that involves interactions or these kinds of transactions, we call a different type of platform. The purpose is not really innovation itself, but there are a number of companies that have developed platforms or multiple platforms that do both, and we call those hybrids. Those are in the middle, and they're largely companies. So I don't want to get into all the details of this, but generative AI is another stack of technologies, and the purpose is to create innovations, essentially, either in the core technology itself, and I'll get into that, or a series of applications built around it. There are transactions that are also coming out of these systems. So this is a technology that will cover both sides. It is essentially hybrid. So again, these are organizations, these are business models, these are technology stacks. We can call them platforms. The critical idea, though, is when you link these two sides of a market, users and innovators, buyers and sellers, they do generate network effects, which is a special feature of platform businesses as opposed to standalone product or service businesses. And those network effects reinforce the particular platform stack. Okay? So let's dispense with that and then get into the real discussion. So I was asked to speak about disruptive innovation, essentially. And I'm a historian, not a technologist, but there's several innovations that have led up to generative AI technology becoming a new kind of platform for applications development. The first, and I guess for this audience, most of you already know what this is, it's the transformer innovation that led to GPT, the generative pre-trained transformer. So of course, artificial intelligence, neural network research is something that's gone on for many decades. You can even trace it back to the 1950s. The transformer work is a particular type of artificial intelligence around neural networks. But the transformer, again, as you know, was developed at Google. We'll get to that in a moment, transforming essentially text into digital tokens, which could be used to predict which tokens should come next. And so the context is very rich here. Training on whole data sets, enormous data sets, whole languages. These systems also produce language. That's where the term generative AI comes from. The Google researchers that did this work, published in 2017, were not actually tied to Google. They went to other firms, including OpenAI. So the initial purpose was language translation, but quickly moved to many other kinds of applications and also multimodal types of systems, not only text, but images, audio, and video. Okay, so you know that kind of background, but it's important to begin with that. This is also a chart I pulled off the web. So the inflection point was really around the transformers. So with AI systems and machine learning systems, We've had handwriting recognition, speech recognition, image recognition going on for decades, but there really was a point here, which is where the systems, this straight line here is where the systems exceed human performance, and that was roughly the 2017 time. And we had reading comprehension and natural language understanding really exceeding the ability of human beings really for the first time with this technology. So that's important. Something clearly changed at that time. The other point that's been brought up is the amount of computing power that these systems require, and that's been doubling and doubling again every 6 months. So none of this comes free, okay? So we have this also going on at the same time. And this also gets into a platform discussion because you need hardware to generate this compute power, and then the software on top of it is where the applications are built. Okay. So we've talked a lot about NVIDIA, and people can have their opinions as to what happened, but NVIDIA invented some things or did some new ways of using computers in these systems that we had not seen before. Most of you know NVIDIA was founded early on in the days of the PC, 1993, essentially using a CPU type of architecture, but dedicated toward graphic processing for video games. They kind of struggled. This was a limited market, video games on PCs. Later on, we had dedicated game devices, and they got some of that market, particularly with Microsoft. But Intel and AMD responded with their own graphic processors, often bundled with the CPU. In 2006, though, the real innovation from NVIDIA came, where they decided that for graphics processing, you don't need a complex CPU that can handle multiple threads and do many things simultaneously. All it needs to control is a few pixels on a screen. And so they went from the CPU architecture of a few dozen or maybe a couple hundred compute cores to a much more complex, much more complex architecture of many simple cores, and each controlling a few pixels on a screen, for example, in parallel. Now, this system could also be used for mathematical computing, and that's how we get into generative AI. The clever part about what NVIDIA did was at the same time they introduced a software development kit, which has evolved into a series of libraries called CUDA, known as Compute Unified Device Architecture, for free. And I think they took a page from Microsoft here. The Microsoft Windows and the previous DOS SDKs were all free. Bill Gates gave them away, said to the world, write applications. The more applications you write, the more valuable my operating system becomes. And you need the software development kit to be able to program in this massive parallel way. So they were merged together. Okay. Now, how did this stack become a new platform? So in 2012, and some people in this room may actually have been involved in this, some researchers in Canada, in France, and then elsewhere started or came to the conclusion that they could use a graphic processor and CUDA to train a neural network. Neural networks run basically in massively parallel fashion with kind of small matrix multiplication problems, and then they feed information to another layer. Again, some of you understand this far better than I do, but they figured that out, and it turned out that NVIDIA GPUs, or GPUs in general, but CUDA in particular, were perfectly suited to the thousands of matrix multiplication tasks and the logic layers involved in neural networks. NVIDIA, particularly the CEO Jensen Huang, originally from Taiwan, responded to this by pouring more money into CUDA, essentially, as well as making the GPUs faster and faster with each new generation. 2014, NVIDIA introduced CUDEN, the CUDA Deep Neural Network SDK. 2016, they gave away several of their most powerful GPU servers, again, bundled with the software, to OpenAI and several other companies, and also universities. And so from this point, essentially almost all of the generative AI software, the large language models and some other applications were built using CUDA software. The catch with CUDA software, and again, this is very much like Microsoft, when you write something in CUDA, it only runs on an NVIDIA GPU, so you're locked in, right? And they've continued to optimize their GPUs as well as CUDA for Gen AI, basically up to an 80% market share of that underlying stack, and the $3 trillion plus valuation of NVIDIA has become associated with this increasing use of Gen AI. This is just a quick picture of a neural network. You can imagine all these little dots being compute cores, massively parallel processing little bits of data and handing information to the next layer. What I'm looking at is a cat, or what I'm looking at is a dog, or whatever the processing happens to be. And again, these are matrix multiplication tasks perfectly suited to the technology that NVIDIA developed. Okay, so there are powerful network effects around this. We can feel uncomfortable with them, but NVIDIA is the GPU of choice because it is by far the most powerful. And by the way, NVIDIA doesn't manufacture anything. Taiwan Semiconductor Corporation manufactures all their GPUs, and they have the latest technology ahead of where Intel is. And so Intel has GPUs, but they can't manufacture them at the same level that the NVIDIA GPUs can perform. So they've got this enormous installed base already, as of early this year, let's say, or 500 million servers. CUDA is really by far the best set of tools and libraries to build the large language model core software or applications. And it's free. I mean, how do you compete with best in class and free? And all these code libraries and applications, 5 million developers at 40,000 firms, a global startup network of 15,000 firms. And so the network effect is the more NVIDIA GPUs are available, and they're available through all the major data centers in the world, the more the hardware is available, the more people will use that hardware to write CUDA software. The more CUDA software that's written, more people want to run it, requires NVIDIA GPUs. And so people buy more GPUs from NVIDIA, and the availability of more of them leads to more software. So you have this positive feedback loop. The one weakness is that CUDA is proprietary, owned by NVIDIA. It's relatively difficult to use. You really need to understand programming at the level of C or C++. They're porting CUDA to Python and other languages, but most developers prefer to use CUDA, particularly if they're writing kernel software. And they may even write and port later on, but it's really difficult to move away from the platform, essentially, that NVIDIA has created. So then what happens next? Again, I've studied personal computers and smartphones, and before that, consumer electronics. And there are these layers. And so the large language models are the foundational models here. In some ways, they look like operating systems that we had in personal computers or operating systems with devices and smartphones. We have the infrastructure players, essentially the data centers and the hardware developers, mostly NVIDIA for the GPUs, but other companies do produce these GPUs. So you need the hardware. On top of the hardware runs these foundational models. And then we have applications, and some of them are very industry specific. So the applications ecosystem, of course, expands. And when you're developing applications, you may choose to build it around a particular foundation model, like to choose OpenAI. So in that sense, you become tied into the OpenAI application programming interfaces. And if they use CUDA, then you're tied into NVIDIA at the bottom of the stack. And so that's how the platform emerges. And again, it's all really wrapped around NVIDIA, but there is more variety in the foundational models. So at some level, they look like operating systems, and I've spent a lot of time in my career studying operating systems. But these large language models They have some characteristics like operating systems, but they're also different. They're also applications in and of themselves. You can take a large language model, like an OpenAI system, and you can train it to do something without building an application or an application shell around it. You can train it to be a customer support system. You can train it to write code for you. So they are much richer than operating systems. And then they've also evolved into another level, which we call reasoning large language models, which show you how they're thinking, how they're analyzing a question. And that actually improves the way we can fine-tune them. So they vary a lot by capabilities, the cost of accessing them if you're embedding them, and other different policies of use. Usually the larger large language models outperform the smaller ones. They're richer and can do more things. But DeepSeek, which I'm going to talk about in a minute, from China. How many of you have heard of DeepSeek? Everyone should raise your hand. Okay, good. They showed us that bigger is not necessarily better. And so this is a good thing for us because it kind of can slow down the arms race. There's also a lot of these systems that are open source, but if you're going to take it and embed it in an application, you still need to pay the creator of the large language model, whether it's Meta, Facebook, or DeepSeek. You can use them for free. I've got them on my phone as an individual, but embedding them, you've got to pay. And there's certain training weights you also have to pay for. Okay. But there is this open source component. I'll talk a little bit more about it now. So what's going to happen with this? Again, in the PC world, it coalesced like 95% at one time around Microsoft Windows and Intel underneath this, and data centers with Intel microprocessors that allowed you to run Microsoft Windows applications. So there's more competition in this space, in the foundational technology, I think because we're earlier, but it could very well coalesce. But the substitutes for NVIDIA are really not very good. No one has invested in software libraries and tools for mathematical programming or GPU programming specifically compared to NVIDIA. So the open source community is out there, but and they have their own libraries. OpenAI has contributed some. Meta has contributed quite a lot, PyTorch. Intel and AMD have their own GPU libraries, but they're nowhere near as rich as NVIDIA. So programmers are kind of stuck there, and it probably will take 3 to 5 years before open source catch up. So Intel and AMD have thrown their GPU programming software into the open source bucket. My wife and I just spent a month in China. We just got back. Huawei has developed its own chips, its own CUDA equivalent called Mindspore, and has some migration tools for CUDA. But again, it's still fairly far behind what NVIDIA has with CUDA. But again, they're making progress. And the problem, though, is the CUDA state-of-the-art software, maybe you can copy that or approximate it, but the most advanced GPU chips are still designed by NVIDIA and manufactured by TSMC, and so that's another lock that is very hard to get around. I just threw this in the other day, and to some extent, the ecosystem around these platforms are growing at an enormous pace, and there's tremendous competition. So this is just showing the amount of money invested in AI startups over the last decade. USA, 471 billion, China, 119 billion, then everybody else is an also-ran. And I think China investments are maybe increasing faster than the US. But it is an arms race between mostly these two countries. This is more than simply Gen AI software, but there's a lot of Gen AI startups in here and other neural network startups in here. And again, they're in all sorts of different applications. You probably can't see this, but almost 7,000 startups in the United States over the past decade have been invested in from the AI field, and 1,600 in China. So this is, again, the ecosystem, and these companies and established companies are making choices as to which technologies to use. Most of them are choosing NVIDIA, and that, again, reinforces the NVIDIA platform. And they're in all sorts of different applications: data management, medical, health, fintech, manufacturing, et cetera. Okay, so this is what we mean when we say a platform. It's this foundational technology with hardware underneath it and kind of applications built on top of it. Let me pause for a moment. This is a high school, it looks like a high school kid with a suit on, but his name is Yang Wenfeng, born 1985. He's the co-founder of a hedge fund using artificial intelligence and machine learning called HighFlyer, and the spin-off of that is DeepSeek. So let me talk a little bit about the innovations that came out of DeepSeek and what it all means, or at least what it means as far as I can tell. So HighFlyer was founded in 2015, has about $8 billion in assets under management. Founded in Hangzhou. We just spent about 10 days in Hangzhou, hosted at Zhejiang University, a tremendous university around technology and engineering, computer science, that has generated a lot of startups. He was a specialist in machine vision. He was applying his skills for quite a while to trading systems. In 2019, they built, his company, HighFlyer, built a supercomputer. They got a hold of 10,000 NVIDIA A100 GPUs. Reportedly, it cost them $130 million. This is an older, slower, and less advanced version than NVIDIA H100 or H800, which are restricted for export to China. One of the interesting things about DeepSeek, though, is they get these enormously impressive results using cheaper hardware. So that's a good sign in some ways. 2021, the Chinese government tried to convince these hedge funds not to encourage so much stock speculation. So Liang decided to take his best team and orient them towards more fundamental AI research. And that group he spun out in 2023 as DeepSeek. As far as we can tell, it has between 150 and 200 employees in early 2025. As of last month or so, I was told it was about 150 employees. But OpenAI has roughly 3,500 employees. So what DeepSeek has been able to do with a small number of people is quite impressive, although exactly how many resources is not always so clear. This is a chronology. Particularly in red are the points that made the news in the US. December 27th, 2024, they published a technical report on their V3 large language model, and then they released the large language model on January 10th. That technical report is just an amazing read. It's one of the interesting things about DeepSeek is they explain to you exactly how they built their system, whereas OpenAI and the other companies, Facebook and Anthropic, they don't really tell you what's inside their black box, but DeepSeek tells you. So it's really quite amazing reading. Then they released a reasoning version of V3, which they call R1, and then they have a very nice technical paper on that, January 22nd, produced. On their website. So the reasoning models, by the way, I think as you know, they go through the logic of how they're answering a question. So this is data from DeepSeek. And the dark blue is DeepSeek comparing their system on their own benchmark to some other leading large language models from Gwen, Alibaba, also from Meta, Facebook with Llama, and also GPT from OpenAI, Claude from Anthropic. The key here, and I'm going to go through this in another slide, they said they spent $5.5 million, $5.6 million, rounding it up, to train this. And again, this was really astounding. They also developed R1 together, and there's a number of costs that are not included in it. But we do believe that OpenAI spent $100 million training its GPT. And Meta probably spent $1 billion on a whole series of related large language models. So the variance is amazing. again, DeepSeek might have spent much more, but if we just look at that one large language model, they really produced it very cheaply. And then, of course, they made a reasoning version out of it. Basically, this is also trained on all the good quality English language internet, about twice as much as what GPT-4 was trained on. It's very similar to Llama 3 from Meta. But the performance is comparable to GPT-4, the reasoning model, but with substantially less training costs specifically. So it's the very, very low training costs and the incredible performance that really shocked people. And this is the performance of R1, again, compared to some other models. And again, it's slightly behind OpenAI over here, but really performs quite well. There's a few things they did, and this is more for the computer scientists, but very quickly, 3 things that they did. One, they used a mixture of experts model. So in other words, rather than have one enormous large language model that could do everything, like try to replicate Einstein's brain, they broke their system down into a number of smaller large language models that are focused on specific tasks. Might be text generation, might be mathematical programming, might be coding. And they use some other training methods to run them in parallel, avoid unnecessary computations, and also to limit the precision of calculations, quantification. So for example, to tell the system, you don't have to calculate like pi to 3.14 infinite series of numbers. Just limit your calculation to 2 decimal points or whole numbers, things like that. That's simple things that they did. Second, made heavy reliance on reinforcement learning. In other words, train the machine to learn by itself. So, for example, give the machine instructions on how to move chess pieces and then let it play millions of games of chess against another computer, rather than have human experts spend a lot of time training the AI how to play chess, okay? So using automated reinforcement learning with a little bit of fine-tuning after you've gone through that exercise. And also breaking the computations down into the different steps of reasoning, which makes it easier to fine-tune the system, and some other optimization things they did. The third thing, which got a lot of attention, they called distillation, which is using a large teacher model and then to teach a smaller model. So it's, for example, use a large model to figure out how to play chess. Here's the 10 rules of how to win a chess game. Take the 10 rules and teach them to a smaller model. So the smaller model doesn't have to go through all those billions of computations. You just transfer the learning. Okay, so essentially that's what they did for R1, transferring learning from V3, but V3 also benefited from distillation of some open source models. Okay. They also found a way to use V3 and R1 to train each other over time using this reinforcement learning. So a very interesting discussion in their technical papers. Key innovations. This is, you'll have to allow me to finish this, but Sebastian Roska, a computer scientist who talks about these, made this observation that DeepSeek discovered that reasoning emerges as a behavior from pure reinforcement learning. So if you're training the system to do this automated learning, it actually figures out how to reason more effectively. There are some hallucinations that are still in the reasoning models. DeepSeek found a way of combining kind of step-by-step reasoning with V3. The initial version of R1 had a 14.3% hallucination rate, but the latest version is down to 1.5%. So we have to be careful on how we look at some of these numbers, but the reasoning models have quite a lot of power, and the DeepSeek models are less compute-intensive than OpenAI. This is another point about parameters. They're like synapses in the brain. One token is about 4 characters. OpenAI's approach is kind of like brute force, massive training. And let me show you this next graphic. It's over here, is a better one. So OpenAI, every time you ask it a question, it has the potential to query 1.8 trillion parameters. By the way, the human brain has about 200 trillion synapses, and so these systems are far, far below the power of the human brain. But nonetheless, a GPT-4 system is accessing potentially a huge amount of data before it gives you an answer. In the DeepSeek architecture, they limit each particular model to 37 billion parameters. And then the total model itself, R1, can access 671. So it's actually quite efficient on the compute resources side. And again, though, this works best because they've got multiple of these models that they're combining in the mixture of expert system. So DeepSeek historically, and I'm going to rely on Dario Amodei's insights on this. In the first several years after GPT came out from OpenAI, most of the R&D was focused on this very expensive, time-consuming human pre-training on very expensive hardware. And this, of course, made NVIDIA a multi-trillion-dollar company. What we've seen with models coming out in the last couple of years is that Gen AI research R&D has shifted a bit more to more economical, machine-based learning with some human fine-tuning, and running smaller large language models, maybe small language models targeted to specific tasks. And so they're more efficient, and DeepSeek is a great example of this. Okay. The other point here from DeepSeek's point is, I'll summarize this. They got good results with distillation, although if it's a small language model relying on extensive reinforcement learning, it's still going to use a lot of computational resources. But it's also saying here, well, distillation strategies are economical and effective. Advancing beyond the boundaries of intelligence may still require more powerful base models and larger scale reinforcement learning. So in other words, we're still in an arms race to build more intelligent models, to move beyond what, say, DeepSeek R1 can do. All right, and then this is my final slide A and slide B. So where are we at this point? A lot of the points brought up in the sessions in this conference deal with this. First, there is this platform power, concentration and power in companies like NVIDIA, Microsoft, OpenAI. So I'm not so sure if it's a problem of concentration of platform power or misuse of this power by not necessarily the companies themselves, but by users. So I think we need to think about that. There's regulation and self-regulation. A couple years ago, I wrote about a tragedy of the commons problem for social media, that a few companies in their own self-interest can actually ruin the reliability of social media and the internet for everyone, right? Destroying that common resource. So we have to worry about either companies or users of these systems misusing them to the point where we don't trust what they do anymore. So governments, as we found from other research, governments really need to pressure companies to regulate. Companies do not regulate themselves without some kind of a threat to be regulated, and they'd rather be able to set their own rules. But how to do this and how to coordinate globally are problems that I think this group will be dealing with. Third, there's an environmental impact. There's no one particular killer app with this technology. It can do so many things, but there's an environmental cost, huge amounts of energy. We can't have half of planet Earth's energy devoted to running these models. And that's where the smaller, more efficient models like DeepSeek are potentially very interesting. They can maybe break that trend that we've been seeing. There's the content ownership and privacy issue. You know, what is fair use of digital data? We kind of settled that for web searches, but we haven't settled it for large language model training. And then there's the issue, if you generate something new from one of these large language models, who owns it? Is it the person that trained the model or prompted the model? Is it the person whose data was used to train? We have the fifth problem of information authenticity and manipulation. Again, misuse, miscreation of information, hallucinations, the alternative realities. You can train these models to be your political consultant and run the next Republican campaign in the United States. It's potentially very dangerous, but does that mean we regulate the companies or we regulate how users use the technology, or do we just throw up our hands? And then finally, there's the unintended consequences of this. We're moving from Gen AI to general AI, where the systems are even more powerful. I'm an optimist. I think this technology will help us to do many things. So I think we'll figure out how to use it, but we do need to build effective guardrails, which is what Jeff Hinton talked about a number of years ago. So that's that's where I end. Okay. Thank you.
Thank you so much. That was fantastic. And you kind of preempted a few of the questions I would have had actually at the very end. But I will let the others ask questions, and I can see already there is one. Do we have someone going around with a microphone? Ah, perfect. Could you just turn around to the gentleman? Perfect.
Does Silicon Valley have too much money? I'm wondering whether the fact that there is so much money, there was no need to become efficient. So you don't need to sit down and think, okay, how can I do more efficiently? I mean, you see more thinking have gone in DeepSeek to try to make it more efficient. So it almost seems like Silicon Valley, well, there's so much money, why do we need to make it more efficient? Who cares?
Well, building these data centers costs hundreds of billions of dollars, and so
but we saw they have
money.
investment over the last 5 years of $500 billion, right?
Okay, well, I personally care, and so.
But do they care?
Yeah. So, but you're right. We could throw, half of planet Earth's resources to this as well. But I don't think that's a good use of money. So I think we should care, and we need to look at what are the cost benefits.
Now they want to build nuclear reactors for the data center, right?
But it's a great point, Moshe. So the more money we have, if people keep agreeing to build these, massive data centers and spend all this money. Maybe we won't look at efficiency, but DeepSeek cared about it. And if you're a startup, you have limited money. And so here's the other point. If it's only an arms race of building the equivalent of a fusion bomb, it's going to be dominated by Microsoft and a few other companies, OpenAI. But if we have more entrepreneurs getting into this, like DeepSeek, they're going to probably be spending less money, do it more efficiently, and maybe we'll use the technology more wisely. So that's what I do think. Democratizing this requires that we reduce the cost. But it's a great point.
Yeah, thank you so much. And I kind of had maybe a similar one. If it's actually at the moment, especially in the US environment, political environment, encouraged to actually develop more environmental friendly or to focus on more environment concerns in the context? Or is it something that actually corporations have to?
Well, we were on a trajectory that, you need hundreds of billions and maybe trillions of dollars to keep building these massive, massive data centers. And DeepSeek showed that you don't necessarily have to do that. You can get a very efficient, good model built very cheaply. Now, of course, they're piggybacking on what others have done before. And so they could not have done what they did without Facebook spending $1 billion on Llama and Alibaba and OpenAI doing what they did. So, but a lot of that basic work is done, and the next generation and the generation after that could be more efficient. Okay, please go easy on me. This could be no tough question.
If I should
Okay.
No, I agree with Moshe that they were using too much brute force, and now they're forced to think. So that's good for us. But one of my comments is that there are many numbers, especially evaluations, that we need to take them with not a little bit of care, a lot of care. So the number of prompts is exponential. And all this analysis of hallucinations or evaluations, so for example, the graph that you showed at the beginning, that it is better than human, I don't believe any of those evaluations. And there are many papers that show that those evaluations are really partial and they're really small. The metaphor I do is like going to the Pacific Ocean, or the Atlantic Ocean, and taking a sample and say there's no bacteria in the sample. Yeah, but the ocean is much bigger, and this is the case of the prompts, and we are not taking all possible prompts. We don't have all possible error rates and so on. So just be careful of these numbers.
Okay, that's always a fair point.
Which of course links to the idea of who makes the benchmarks.
Yeah.
Yeah. Such a big room, maybe in the end, pick one of them.
But there's no denying we've made progress. Yeah.
Thank you. I'd like to ask a question about DeepSeek, whether the impact or the innovation that actually comes from them, whether that isn't simply overblown just by the fact that the US companies don't publish their technology. So simply by the fact that they release these white papers and published that openly, that they got much more attention than much of the research that happens behind closed walls in the US, and that much of that media attention actually comes from that.
Yeah, no, I think you're right. They got a lot of attention because of what they released. But there are a couple other things involved. One, in almost all benchmarks, the DeepSeek large language models have done really well. And then second, the cost of their APIs was really, really cheap. And so if you're going to embed one of these models in an application, you have to pay the owner, essentially, even if it's open source, for the training input tokens and then for the output tokens. And so they were priced at a fraction of what OpenAI was. So OpenAI has cut its prices in half twice in response to DeepSeek. So that's another thing. So you get good performance at a very, very low price. A lot of Chinese companies have embedded DeepSeek into their search engines and other applications. AMD is also using it in the United States. There's restrictions, and that's another slide I don't have on this in this deck for all the political restrictions we have around using DeepSeek. But it's the cost performance, I think, as well as revealing how the black box works that has attracted people.
Maybe one more from the back, and then there's one in the front as well. Yeah, of course.
Okay, thank you. So my question would be what about AI agents? Because we've seen the architecture of the whole Gen AI ecosystem is composed of infrastructure and foundation models and applications. But what if, between the foundation models and applications, there are AI agent, which could be a middleware layer, it could integrate the foundation models and also the tool extensions and memory systems, which could make the large language models perform more specific tasks and extend their capabilities. And what if this form can be, I don't know, technically a solution to AI innovation or more efficient forms? What would you think of it?
Well, I've been thinking of agents as part of the application layer, but not as a separate, because if you're going to use a large language model to do something, then you're in the territory of agents. So I'm bundling them together, but it may be useful to separate them at some level, too. Okay, I think we need to end here and go on to the next talk.
Okay.
Thank you.
Yeah. Yes, we need to move on. Thank you so much, Michael. Yeah, we can ask questions later in the second Q&A, so if it's really urgent. So now I happily introduce the next amazing speaker, who is Professor Bashar Nuseibeh. He's a professor of computing at the Open University in the UK. Until last year, he was a professor of software engineering and chief scientist of LIRA, which is Ireland's National Centre for Software Research. He holds honorary and visiting professorships at UCL and at the National Institute of Informatics in Japan and the UCD in Ireland. And he was recently appointed the research pillar chair of the UK's Responsible AI programme. Bashar's research lies in the intersection of software engineering, adaptive system security and privacy. And he's interested in physical and psychosocial aspects of technology, and I think he will talk also more about that today. He's the recipient of 2 ERC grants, I think, at least, which for academics is, yay, the holy grail. And there's so much more to say, of course, as well, but I keep it short. And he also is co-editor of the, maybe you've seen it, the Introduction to Digital Humanism, the Bible, that also is lying out there. Yes, and welcome. The stage is yours.
Thank you very much. Thanks. Hello, everyone. Thanks for the introduction. It's a real pleasure to share the stage with Michael, whose book on Microsoft secrets in the mid-90s was hugely influential on both me and the software engineering community, because it actually emphasized also the importance of context, the business context, the cultural context of organizations and how they develop software. And so what I'd like to do today is in a sense talk about another kind of context, which is the social context. So whereas the business context is all about value, business value, I think social context is where values sit. And I think it's really important for us as a digital humanism conference to look at where these values come from and to engage with them, perhaps sometimes maybe naively independent of the business value, because I think after all, there is the goals that we have sometimes in life are not always driven by money, believe it or not. Okay, so the overall session here is on innovation and AI, innovation in the age of AI. So I am going to talk about innovation, but I'm also not going to talk about technical innovation. I'm going to talk about social innovation. Because I think, again, that's the kind of thing we want to try and bring about, perhaps. I'm a software engineer, and I'm going to talk about psychology, and I'm going to talk about sociology. So I'm completely unqualified to talk about this. So I just asked the sociologist in the audience and the psychologist to bear with me a little bit because of my naivety. But that doesn't mean that these things are not important. So I'm going to try and sort of dip my toes into that space a little bit as well. So the title itself is, I think, controversial to almost everybody, because engineering the social is quite an uncomfortable thing. In fact, I could have annoyed you even more by calling it social engineering or responsible social engineering, and that would have upset everyone in the room. But I'm going to try and not do that. So I'll try and explain what I mean by engineering the social and how some element of responsibility can lead to good outcomes. So I said I'm not a sociologist, but my first slide is taken from the father of sociology, someone called Robert K. Merton, who came up with terms like self-fulfilling prophecy and popularized self-fulfilling prophecy and unintended consequences and role model, these kinds of phrases. And one of the things where he placed innovation is when there are accepted goals that people have, but they reject them and then they try and somehow find alternative ways of meeting those goals. There are people who accept those goals and conform to whatever technology presents to them or whatever processes are presented to them. And there are people who accept but ritualize the way they satisfy those goals. And there's others who disappear and retreat and just refuse to engage. And there are others, and we see a lot this in society these days, who rebel completely and say, I refuse to accept the goals that are being set for me, and I'm going to create new goals and new means. So innovation often happens at the top right-hand square, but also sometimes when people rebel and don't accept the goals. Sometimes for good and sometimes for bad. And I think, so we can discuss what constitutes good and what constitutes bad in a while. But I think this is a useful framework to think about in terms of when we try and understand the social context in which systems are developed, whether we're actually trying to just make people more efficient in conforming to their goals, or whether we're trying to do disruptive technologies and trying to innovate and perhaps find new ways of satisfying existing goals, or whether we're throwing away our goals altogether. A couple of weeks ago, I was traveling in Heathrow Airport, and sort of this vacuum cleaner cum information robot was moving around Heathrow. And there's this guy checking his phone, completely unattentive to it, and it suddenly approached this man and said, "Attention, please move aside." And the guy jumped and immediately obliged. So they immediately took that instruction. They were not used to seeing this kind of robot, and so it sounded authoritative, it was invading their private space, and so they complied. A few minutes later, he sort of realized what that was. My eye caught his. We smiled and, shrugged our shoulders, and he actually moved aside. The robot didn't do anything, but we had this little engagement about this technology, and in Milton Keynes, which is this little town just outside, just where my university is based, we have these little robots that deliver shopping. It's a company that's been going on now for about maybe 5 to 10 years, and it's become part of the social context of that city. People sort of engage with it as an interesting service provider, but sort of children enjoy the idea of having something delivered to them by robot. And it moves around the town, the city. Some people ignore it, some people engage with it. Sometimes it gets stuck and people actually come and help it to cross the road because it doesn't know whether to cross a busy junction. Some people abuse it and kick it and are violent to it, and so it's become part of the fabric of that society, this robot. And it's an embodied type of technology, so it's physical, and so I'm giving you as an example of how people can engage with that technology. But it really does show you, to some extent, how the world in which we live and embedding this technology changes the way we interact with it. So I go back one step, a little bit more sort of more traditional in terms of my background as a software engineer. And this kind of graphic is what I grew up with as a software engineer. It's called The World and the Machines. Pamela Zave and Michael Jackson have articulated it. It has a formula. This is the E equals MC squared of software engineering, which is that there is a world and there is a machine and there's some shared phenomena between them. And when you design a piece of software, they have to meet some certain requirements. And sort of this was the bread and butter of a lot of software engineers. But what I'd like to perhaps propose, and particularly to the software engineers in the room, is that it's actually getting a little bit out of date now for the kind of scenarios that we were just discussing. We have so many machines now that it is not always very useful for us to understand which machine whose phenomena we need to try and specify. Now, we can add some structure and layers and so on, but it's not a particularly useful exercise. And increasingly, we have the world itself embedded in machines. So you could think of large language models as a model of the world of some kind. So now we have the world inside the machine. So our abstraction, our beautiful little abstraction, is becoming less and less useful for what we want to do. And similarly, our whole old-fashioned model of the different ways we interact with machines has also been changing. So we can talk about human in the loop and on the loop and with the loop and all sorts of kind of combinations of that. But actually, there is something really missing in all of this, which is people. It's not just one person who interacts with the machine, it's the many. And we can take samples, we can say there's a whole population of people that behave in a particular way, but what's more useful is if we start understanding particular types of groups. These groups can represent social identities, they can represent roles, they can represent functions that people have in society, they can be families, they can be professions, and so on. And if we have a better understanding of the kinds of people that we have from a social or social psychological perspective, like their social identity, we suddenly have leverage over trying to understand how to design technology and innovate in particular way. And so moving from the world and the machine, perhaps we should start thinking about society and the machine and unpicking this notion of society, which has much more structure than just external phenomena outside the machine. Because what society actually wants is not technology systems and software. What they want are better ways of working, ways of interacting, ways of living. And as soon as you start talking with this language rather than the top, the top cluster, you start thinking, well, how do I want to live? What kinds of things do I want to try and, what kind of software do I want to build? And what does it mean for that software to conform to certain values? And so, I've been for many years pushing this notion of a responsible software engineer. I don't particularly like the idea of responsible AI, as I think was discussed yesterday or the day before, which is you can't attribute responsibility, which is a social construct to an AI, I think, in my opinion. But you can for a software engineer. They actually have certain functions, they have to do certain things, they have certain responsibilities. And that has changed over the years. So the software engineer used to engineer, they used to think, how do I engineer software? How do I actually build it? And as we've evolved, we started thinking, well, what software should I engineer? So this is my sort of pet topic of requirements. But also now we're starting to think much more deeply about what kind of world do we want, which is enabled and supported and reflected by software. And I think that makes a huge difference as to what the role of the software engineer is. So a good engineer used to be developing software that demonstrably works as intended, dependable, and useful and usable. But I think it's also potentially an engineer who does good, whatever that might mean, whatever that social good might mean. And that is quite uncomfortable for a large part of the software engineering community. It's not necessarily something that they necessarily learn at university, although sometimes some philosophers or psychologists give some courses in computer science departments and teach them about what's good and bad. But I think the jury is out as to whether the software engineering community is really engaging with what good means, what social good means. And so this discussion of what is good and what is bad depends on the way we're living now and the way we would like to live. And that's a philosophical discussion, it's a social discussion. And then the question is, do technologists who are supposed to innovate engage with these kinds of questions? And I think the reason that I really enjoy being part of this digital humanism community is that these kinds of questions are asked by technologists as well as by others, not just policymakers and politicians. But I think we still don't ask enough about them in this community. I think we've heard a lot about policy, we've heard a lot about politics, about governance, about democracy, which are all fine and important things. We've talked a lot about businesses and business value, but we've not talked about social good, public good. What does it mean to live the lives that we want to live? And again, maybe I'm being utopian or particularly naive, but I think these are important discussions that we should incorporate in the disciplines that we are trying to push as contributing to digital humanism. And I think that means having to foreground context. It just means context it becomes really central, because context is, as I said, where value is. And I really am a huge fan of this particular paper, which is now 20 years old, which reflects on what context means. And Paul Durish talks about context in a way that is much more about where the action lies. It's not just about information, what information is available in the context, but it's about relationship between the activity you do and how it affects that context. It's not something that you can identify, pre-identify when you're modeling, when you start developing software, but something that evolves over time as you interact with your environment. And this is something really hard for us as software engineers, because we love to understand the domain, have a boundary, and have the system within that. But if we're saying that the action we perform changes that context, then we have some interesting challenges for us. It's not so stable. It changes, as I say, all the time. And it's not separable from the activity, it's actually arising from the activity. And so I think for all of you who want to try and understand how technology fits, I think it's worth thinking about context and rethinking context in ways that engage with the technical discipline. And sorry, this is very, very, very simplistic, but I call this context 2.0, where context is centered as part of the discussion of what technology you want to build. It means being socially aware of what is happening, not just the phenomena that happens outside and that are monitorable by whatever devices you put to monitor the environment. It also means that adaptive systems that we build are not just technological systems, they are trying to be socially adaptive. They're trying to understand how people want to change the way they live their lives. And the naive bit, I guess, but I still believe in it, is for a better world, which is delivering on social good, and that social good is often sort of a future where you have a value-rich description of context. So the implications for software engineering, at least, and this is, again, I know this is only a subset of this audience, is we need to move away from these typical models that we build, which are quite behaviorist. You know, this is a state machine. You know, you have the machine moves from one state to another with transitions. If we're lucky, we put some uncertainty values on the various transitions, and we have these wonderful outcomes that tell us with all probability that this is what needs to happen next. I think we need to be moving to more an ontological view of how to model systems and context, which looks at things like opportunity and willingness and capabilities, the kinds of things that we humans understand, because we are going to have more, as software engineers, conversations with those kinds of people. So I think in terms of modeling, at the very least, we need to have a richer set of models that, of course, include behaviorist models, but also have ontological models as well. Just to give an example of the kind of stuff that we're talking about here, so we've been looking a lot at emergencies and how robots and drones and technologies can help in emergencies. And typically, you have this kind of sort of, the technology mediates between first responders, the ambulance, the police, and so on, with the people with the people, for example, who have they've fallen, or there's a fire, or they need rescue. There's other technology. Most of these technologies are always with the first responders, the people who are going to actually intervene to help. But actually, if you think socially, there are many people who are the citizens who are sitting around during the emergency, perhaps not affected by it, or perhaps affected by the emergency, which we call zero responders. And these are people who can actually help. They can help, for example, before the services, the emergency services arrive. They can help by interacting with the services and perhaps reducing the resources necessary to help others. And what we've started thinking about is how can these people, do they have a social identity? And it turns out when people in emergencies do actually bond together, they are not, often there are some bystanders, but there are also people who do help when there is an emergency. And you saw that a few days ago 2 days ago in Liverpool with the guy driving into the crowd. You see that in the Manchester Arena bombing in the UK. You can see this, for example, when there are emergencies. People tend to behave work in groups. And if the technology is able to identify the social identity of those people who are likely to help, then you can target resources before, for example, the emergency services arrive. And we found that with the appropriate sensing, social sensing, understanding, people who use the word we rather than I, for example, are much more likely to be thinking in terms of groups, for example. You can start delivering technology at a slightly more optimal pace. Now, of course, if it's a very large emergency, then being so specific doesn't really help. And if you have a lot of first responders, then again, it doesn't help. But it's a process of trying to adapt to the situation and to the people. And I think there's some really interesting possibilities there. I'm moving a little bit quicker than I intended because of the time, but I think in terms of values, I think it's quite important for software engineers to engage with these a little bit more than they currently do. So values, I think you know, a lot of you know, I think, intuitively what values mean, but there's certainly sort of notions of universal human values, and there's lots of models of human values and lists and descriptions of human values by various social psychologists in particular, who've classified them. But I think what is interesting is that each person, organization, or state attaches various importance to different values. And actually trying to understand those differences is quite important when you need to make some trade-offs. And some of these values are implicit and some of them are explicit. So this is a mini fast tutorial. But what's interesting is that we've explored how these values affect the way you design your research even, and not only and the systems that you build. So if for example, we found that if you want to design systems, for example, that look at things like gender inclusivity, then modeling with things called emotional goal models are actually much more useful, because actually people get triggered quite emotionally when things like lack of gender inclusivity is being sort of described. When you're talking about fairness, often resources are particularly important. So you need to add resource models when you're modeling values and so on. If you have multiple values, then it gets really complicated, because people will tell you, I have 15 values that I really care are important. But when they go, say, shopping, for example, it turns out that their actual behavior diverges from their stated values. So we've created something called the values shopping basket to see if the people's stated values when they start their shopping experience and actually what they have in their shopping basket at the end diverges. And then what happens is you get that back to people, because values are often quite reflective, and you reflect on whether your behavior actually needs to change, or whether your values as stated are different. And these are the kinds of things that you can implement as another layer in your systems, but allows people to reflect much more on the social good that they feel that they are engaging in. And there's all kinds of possible representations for that. So, those, I think, are for software engineers to think about in many ways, but I think also the digital humanism community needs to think a little bit about how it engages its research agenda with all these diverse disciplines represented in this room. And one of the things, and I'm talking here just purely from personal experience, is I found that discipline hopping is really, really useful. Just turning up to different kinds of disciplines, different conferences, learning much more about their areas. The reason I have a volcano here is my first Chi conference that I attended was in Atlanta in 2010, and there was a volcano that erupted in Iceland, which basically stranded me in Atlanta for 2 weeks, immersed in this conference, which was not my community, but I spent 2 weeks with HCI researchers and actually quite inspired by the types of methodologies and research that they did. So, I don't advise that you get stranded in another community, but you should at least certainly at least go to other conferences and explore their methodologies and so on. I've also found that disciplines that are perhaps not even close to what you do are sometimes useful. So Bruce Schneier and the late Ross Anderson invited me to their first workshop on security and human behavior at MIT, actually. It's many years ago. And it had all kinds of multiple disciplines represented, but one of them was James Randi, a very famous magician. And the reason that was useful is because Randi was an expert on deception and understanding how people are deceived and how they react to deception in different ways. And so if you're doing research on security and human behavior, understanding deception is actually quite an interesting thing that I hadn't actually thought about at the time, which has now become, of course, quite a common thing to think about in the security community. And then I have this very technical technique called the walking method. So this is Mark Levine, my very close social psychology friend. And the way I learn about social psychology is once a month we go for a walk around London, the different parks, for about 6 or 7 hours, and we discuss our methodologies, our disciplines, our goals. Because actually when you're trying to think about how to create an agenda that's truly interdisciplinary, you've got to somehow let go a little bit of your own prejudices and of your own sort of ways of working. And I think these kinds of approaches, both educationally and practically, are really, really useful if you want to sort of boost your interdisciplinary credentials. If you wanted to go even further, maybe become transdisciplinary, then I think that's where the money is, as it were. So COVID was a wonderful example of transdisciplinarity. Lots of different disciplines, medicine, technology, and sort of logistics, and all of them came together to build vaccines and to do contact tracing. It was wonderful. But it's really hard to do for small labs, for universities and research groups. So I've been thinking about how can you actually do transdisciplinarity in the small. So try and put teams together to solve particular types of problems. Perhaps in this idea of a living lab where you have a particular social problem that you're trying to address, and you get multiple disciplines from your own university over a period of time and invest in those labs. And I think there is some potential there to actually not have to have the millions or billions of dollars, euros, pounds to try and do transdisciplinary research. It's possible to create these multiple living labs for transdisciplinary research if you can identify societal challenges as opposed to problem challenges by organizations. So this is not the traditional idea of, well, we'll all try and work on aerospace. It's much more about, well, what sort of social problem I'm trying to address, and then you configure your disciplines together to try and do that. And I think it has some potential to do that, and we're doing some experiments in that space. Okay, so I think thank you, I'm getting very close to the end. I think some of the things that we need to think about really is, what does it mean to do social sensing? What does it mean to understand how people are interacting together? What is the social context? It's more than just data collection of where you are and what you're doing. It's often about who you're with and why you're with them, and all kinds of interesting topological relationships that are not just physical, they're social topological relationships. So we've been trying to use things like topology, which is quite a well-understood sort of a mathematical discipline, which has been used in many disciplines, like architecture, knowing that your bedroom is near the kitchen, near the the living room. These are important physical topological relationships. And we have digital topological relationships as well in terms of connectivity and so on. And we also have social topological relationships that I think are worth modeling. And the ability to sense and understand where you are socially is very important in order for you to adapt and to change, and for the technology to adapt around you. And so I started by talking about the social engineering, the social engineering dilemma, because the term has been already sort of has very bad connotations in security engineering, and the panel yesterday was already talking about it in very derogatory terms. And of course, once it's taken that notion, then it's a problem. And psychologists hate it a lot because they don't like the idea of sort of engineering the social. And they don't like the term, so don't write a grant with that phrase. Yet our real world is full of examples where social engineering is taking place to make money by the large organizations, by people who are intervening in all sorts of ways to help us, to make us behave in particular ways. A lot of the work has been often taking advantage of our cognitive capabilities, so it's more cognitive psychology rather than social psychology. But I think there's an opportunity to really engineer and change people's behavior ultimately for the good. Now, what does that mean? It means actually being a responsible software engineer, being a responsible designer of technology, and also understanding the use and deployments of that technology. And so if we frame the social engineering around other good engineering characteristics, then I think with all the guardrails of transparency and consent and a whole range of ethical values, I think we are, I think we can potentially sort of move to a better world. And this is a slide I did maybe about 7-8 years ago, so pre-pandemic, all sorts of political changes. But I think depending on whether you have a utopian or a dystopian view of the world, can affect you. So, some people think this is a terrible age we live in: climate apocalypse, pandemics, death of privacy, death of society, rise of the machines. But if you're Steven Pinker or others, then you think, oh, life is wonderful. We're have all sorts of medical advances. We're living longer. We're richer, and robots and machines are helping us in all sorts of ways. So the utopian and the dystopian can sit quite comfortably together, and I think that's not a problem. I think that's an advantage. And the ability to think about dystopian and utopian futures is really quite an important part of what digital humanism is about. We have some humanism goals, but we also have some dangers and things that we have to be careful about. And we need to construct our research and our practice to be able to move between those two spaces and understand where we sit on that spectrum. So we've been doing quite a lot of that. A lot of people have been doing a lot of that work, so a plug for the book. But we've been looking at all sorts of other alternatives. So we come up with this notion of kind computing, for example, how you engineer aspects of kindness in systems. We've looked at things like infrastructural justice. So when the framework itself, or the platform, or the whatever system, institution that you have is compliant with all the regulations is necessary, yet is still morally unjust. How do you deal with that? I've spoke a little bit about the human-AI collaboration in that emergency scenario. We've looked at situations where particular groups, for example, are particularly susceptible to bad behaviors, for example, with the Center of Protection of Women Online. And in the opening talk, I think one of the speakers was talking about actually digital humanism also includes animals and the environment that we live in. And so we've been studying things like animal privacy and how there are natural biological behaviors of animals and how they behave. And the reason that's interesting is it's, of course, important for animals, but it's also important because it means we can develop tools and technologies where consent is not easy to extract. So there are all sorts of interesting opportunities there as you cross disciplines and explore. So with that, I will stop, and I'm sorry if I overran.
Thank you so much. That was fantastic. And now I'm actually stuck with this idea of animal privacy and cat videos. So I think everything would collapse if we take this serious. Maybe we shouldn't. So many questions. Great. Where's the great? Just go with Michael first. Yeah.
Thank you. I like this journey with you. And I want to confront you with one quote by a long-dead French philosopher, Blaise Pascal, and I read it because I want to say each word exactly. All of humanity's problems stem from man's inability to sit quietly in a room alone. So Blaise Pascal was multimorbid, he was super religious, but he was also a great mathematician, so there's some connection to engineering. I would buy into all these models if it includes also a serious option to not do something. And I would be happy to get some reaction from you on that.
So I don't think you would get a disagreement from me. I think there's a range of social behaviors, including the right to be left alone, literally, physically in a room. So I have no problem with that. I don't think it's inconsistent with what I said.
Sorry, don't misunderstand. The engineer shall not do everything he can do. That's my point. The engineer shall sit very often just here, do nothing, and just relax, yeah, and not solve problems. That's my point.
Okay. I think I'll leave that to gestate in my mind and maybe talk to you at coffee, because I'm not sure I have an answer to that.
Thank you.
Thanks for the talk. It was very pleasant to listen to you. I have actually, can I make an example and then ask a question to both of you?
Okay.
So large language models. What they do is and in terms of innovation, they provide a solid basis for the innovation to come. Obviously, they are drivers of innovation, and that's how they're being used. But they are very different. They are built with very different values. So for example, if you have DeepSeek, cannot be used for any text that will talk about the politics in China and about who's leading China. So it's completely, this type of innovation is impossible by using DeepSeek. I think you can use Llama or something for that. But some of the Silicon Valley models cannot be used to talk about violence or to talk about, I don't know, gay and lesbian relationships and what have you. And there are big differences in how this comes about, because in one case this is entirely decided by the companies, in the other case it is at least partially, I would guess, pressured or suggested strongly by the government. But in the case of, my question for you, Bashar, is, how we design these systems is not a single designer. Sometimes there are hundreds or even thousands of people. So that makes what you have just said very, very hard, I believe. Maybe you have an answer to that. And of course to you, Michael, so what does this mean for innovation? I mean, none of the tests you showed us was thinking about what these models, how these models have been constrained, what they can talk about, and what they entail as a consequence. Thank you.
So I can take a stab at that. I mean, I don't think, again, I don't think the scale of innovation is particularly in question here, because I think social innovation is almost the requirement. It's that what I'm talking about here is at quite a high level. What are the requirements for these kinds of systems? How you actually decide in the end you want to implement them, whether by hundreds of people working together to construct a system or a set of systems, is actually slightly different. I guess I'm responding to, I'm particularly aware that increasingly people are saying software engineers are likely to become less and less relevant. So actually these systems potentially in the future are going to be generated in some particular way, and it's probably too distant at this stage, but not unrealistic. And so the key then is really what it is that you want to build. And so what I want to engage people here is with obviously my passion, which is the requirements, the goals, the cultural needs. And these will also involve lots of people, will have multiple views, and there has to be processes by which some of these things are resolved, or how they actually sit uncomfortably or comfortably together. And often it is quite possible to have lots of inconsistencies and conflicts between those multiple requirements and still build systems that actually operate. So I'm a huge fan of making inconsistency respectable, at least at the requirements phase of exploration. Not sure if that answers.
Let me quickly address that question. So you're right, DeepSeek cannot answer, will not answer politically sensitive questions. And like social media systems, some of the LLM developers have built in some controls. But I think the trend is to eliminate controls like that. And getting back to Pascal's dilemma, I think if the technology is there, someone is going to use it. So the box is opened, you know, the cat is out of the bag, so to speak. And so we're going to have this technology used for all sorts of different purposes. People are going to find ways to override some of the controls or guardrails. So, you know, again, I'm an optimist. I think we'll figure this out before we blow ourselves up, but that's always a possibility, right? Okay.
Yeah. So I have a perspective from the history of technology. Two classic works in that area, The Revolt of the Engineers by Ed Layton and America by Design by David Noble, both address a moment in the early 20th century where there was a push within engineering to try and have it be a profession in the self-image of law or medicine, where there are real ethical and social responsibilities, where there's self-governance within the profession. And both authors would say that's not what happened with engineering, that engineers became embedded within corporate capitalism and did not get to have separate values or real professional autonomy. It doesn't, while the world's changed in many ways, traditionally the engineer would aspire to a career path to management. Now maybe they aspire to a career path to become a venture capitalist. But it doesn't seem like things have got any less capitalist. And what's happened with companies like OpenAI that, you know, were founded with lofty values, I think bear that out. So the lesson that might come from history is that you can't solve this with a different kind of software engineering methodology. You need a different kind of society and a different kind of democracy and a different kind of capitalism. Would you agree with that?
I think I would partly, I guess. So I spent a large part of early of my career trying to promote software engineering because I think software was not particularly well engineered, and I sort of really bought into the Kool-Aid of actually trying to make software engineers more like other engineers with all the bells and whistles of what makes good engineering, and therefore possibly landed in exactly the situation you're talking about, which is embedding them in all the sort of the negative situations that you describe. However, I think there is potentially an inflection point here where software engineers might become irrelevant unless they become part of the social conversation and not only part of the business conversation. It is quite possible that people will be generating these things called software systems that don't actually work for a particular business, that they might create ways of working, ways of living, ways of interacting themselves. So end users become, to some extent, engineers. Now, this doesn't work for an aircraft, it doesn't work for very large safety critical systems, but there's certainly a move towards software engineers perhaps being a slightly different kind of profession. And so having worked so hard to move software to an engineering discipline, I now also want to step back and say, well, actually, we've got to a point where now we could be something different, and we should be something different if we want to stay relevant. And so I guess it partly addresses your point. It doesn't quite address the business side of things, which is, you know, capitalism and you know, the market forces do have a huge impact on how we build stuff and why we build stuff. But there's also a situation where we, the people, are also building stuff.
For the sake of coffee, please questions and not so many comments. Thank you so much.
So thank you so much for a wonderful talk. And I have a question about values and requirements engineering. So I worked a lot in let's say, in African countries with a team of requirements engineers trying to design software for low resource environments. And my question is, how can you design, let's say, for values when you are not familiar with the culture, when it's very different from your own?
So it's expensive, but important. So, I mean, often people who do that take, you know, ethnographic type of approaches where they embed themselves in a community and try to understand those values with all the disruption that causes and the cost that causes. So there are tried and tested ways in which you can surface values, but they are often expensive. But one of the things that one of the sort of the themes of what I talked about, particularly the dichotomies we live by, is that we developed this method called contravision, which creates contrasting views of what future technologies might look like. And you find that people, when you present them with not a possible solution, but a whole range, possibly at the extremes, then they engage very much differently and they reject certain options, and therefore you get a better sense of their values by prodding and probing in particular ways. So, and that was sort of the work in the CHI conference, the Human-Computer Interaction Community, that is methodologically quite interesting, because traditional requirements engineers go and interview and talk and discuss when it's not quite what you need. What you need are different cultural probes, other kinds of probes, perhaps that elicit and surface those values, but it is costly.
I have to really add something to this because it's so crucial. I'm sure you will agree. You have to avoid also colonial structures you keep reproducing, because this is what's happening with so much technology, especially when you go to African countries to solve their problems.
So I keep it short. So my first question, thank you for showing a disruptive innovation with DeepSeek, and my question to you is, because there's always this, you also mentioned, you won't find political information, but I think all other technologies have their constraints and you cannot order questions, so it's not just. So do you share this? So that's my question to you, because yes, the Chinese constrained it, you can ask political questions, but all others have their constraints as well. So is this a fair comparison, number one? And the second question is to you, I'm so glad you bring the human into equation as a technician, because as I understand in Dartmouth College, social scientists like me were kicked out because the brain was seen as a machine, we don't need them, and now you bring them back. And I really liked that you bring into the equation the society, because that was a little bit missing over the last 2 days, that yes, politics and regulation and technology, but society has no voice or little voice, because business and technology, I'm interested in what you see, how this could progress, because you see, have various perspectives. Yeah. So those are my 2 questions.
Okay, I can try again, but I think it is a fair question to ask, what are the deliberate biases built into a system? We know that all artificial intelligence systems have biases built into them from the people that created and programmed them and trained them, let's say. But this is a very specific political bias, and the other systems, may also have very specific biases. So we want to know what those are. And I will say again, there are programmers that are going to find a workaround for those. When most of these systems, the code is open source, you can take it, you can reprogram it. So we're going to get around it, and we have to be worried about what people will do when they don't have these guardrails. Some of them are for good purposes, some of them are just arbitrary, like in China saying, don't ask me any questions about Tiananmen Square. So we want to know what are the constraints or systems in these systems.
Thank you. So the very, very quick answer is, obviously I agree with you, because that's what I sort of, that was the thesis that I think the socialist needs to be a fundamental part of it. I think this kind of initiative, the Digital Humanism Initiative, is exactly the kind of environment where these kinds of cases can be made to politicians and to people in power. But I think from a research perspective, I think transdisciplinarity in the small is, I think, where a lot of these ideas can actually be developed. So actually getting people and funding associated with transdisciplinary projects starts being much more inclusive of the various disciplines, because it's much harder to solve a societal problem or even a business problem without having all those disciplines involved. So by design, you construct your research and the way you're considering the questions by having those multiple disciplines together. Whether it can be done at a national or international scale is a challenge. People have disciplinary prejudices, but what you do is you create structures institutions that actually support transdisciplinary research. And some of the funding agencies are already trying to do that. So Science Foundation Ireland, or now Research Ireland in Ireland, started to sort of promote transdisciplinary research. They merged the social sciences and humanities and science councils together. In the UK, they've talked about it. Some of the leading universities in the UK, Imperial College, for example, has created schools of transdisciplinary research. So those kinds of structures are what we need to start promoting at universities and possibly in funding agencies.
Okay, one more last question. I'm so sorry. There's someone, with the hand up now for a while. I had neglected the back part. I'm super sorry, but coffee is waiting.
Thank you very much. Since you asked for interdisciplinary interaction, so I'm a physicist and I'm exposed to this for the first time. So it could be that my analogy makes no sense at all, so I apologize for that. But if I would study the molecules in this room and we would close the door and if we would do some statistics, then we could come up with a quite nice relationship between pressure and temperature. It would be highly explainable. We could predict the future if we change these parameters. But if we go to a big system, to a complex system, to a multi-scale systems like the Earth's atmosphere, the rules are the same, but we see structure formation, we see self-organization, we see instabilities, and so on. And if we want to assess how the system reacts on a parameter change, we need heavy modeling. Otherwise, with our linear heuristics, our brain is capable of, we have no chance. And if you now say we're in a world where the world is in the machine, we have billions of people interacting with it, huge amounts of data, huge amounts of autonomous agents, do you see a really chance that policymakers and lawmakers can come up with good regulations, with good guardrails, without heavy modeling support to really see what consequences the regulations will have, and so that we can arrive at this good and utopian future?
That's a tough one. I think it's probably more a coffee conversation, but I think I think some of what you're describing is sort of more physics-based or physical-based sort of type of digital humanism. So I was talking more about the social. But I think there are lots of good examples of how the physical world and the physics, both in terms of the physics and at the mega level, as you say it, or meta level like astronomy, but also in terms of physical plants that you might want to protect or you might want to design, how the physics implements or affects the way you think about how those systems operate. Now, you can create models and you can create physics-based models that sit quite comfortably with the digital models, and there are experts in the room on cyber-physical systems who can tell you quite a lot about how the physical and the cyber come together. But I do understand that your point is slightly different. Yeah.
I think we have to stop there at this point. I'm super sorry. Thank you all for being here, for listening, for sacrificing a few minutes of the coffee break. And the last words to Erich Brem.
Yes, thank you. Sorry, I'm keeping you from coffee, but for a good reason. First of all, thanks both speakers and Jenny. Jenny wasn't mentioning it. She's a wonderful colleague from the University of Vienna. She's one of the not many philosophers of technology that we have in Austria. I would like to do something else, because this is the last plenary session, except for the evening event. So there's one thing I really have to do. I need to thank two people who have really been behind this event very, very much. This is Sabine Melnitsky. She has been communicating with all of you. And with an attention to detail that is remarkable. And Pitt Franzen, who is behind everything that technically was set up, and many, many other things. Thank you both. It has been really a great pleasure working with you. Okay, now you're nearly free. After coffee break, you have a choice between the social and the money. You choose the same basically after lunch. And talking about money, I want to say that at the evening event, I know not many of you will be here, I'm still saying it, there is the opening of a new call of a Viennese funding agency, Tech for People. So these people are actually doing something. Thank you very much. Enjoy your coffee.